Today we are going to start chapter 6. So this is about the probability. Okay, let us go through the definitions first. Okay, experiment. An experiment is a planned operation carried out under the controlled conditions, right? So experiment is kind of you are doing mathematically the things to get some result, which is called, the experiment. A trial is one of those incidents. So experiments may have so many, steps, but if you look at only one instance among those, which is called trial, okay? Now, outcome is any kind of possible results you are getting when you do an experiment. A random experiment means we cannot predict the results before doing an experiment. We don't know the answer actually. So those kind of experiments are called the random experiments. Okay. Now, the sample space, of course, we have seen sample space in chapter 5, right? So sample space means what? The collection of all the outcomes whenever you perform an experiment. You have to put everything under the set, that is called the collection of all outcomes, which is sample space for the experiment, yes. An event E is set of specific outcomes we are collecting from your sample space. So basically, event, we use a big E as event. Event is kind of subset of your sample space. Okay, E is kind of smaller guy, subset is the biggest one. So if you are asked to find an event, that means you have to collect the outcomes from where? From your sample space. Okay, so sample space is kind of, okay, so the sample space is kind of big set. Okay, you will collect all the outcomes here. Then for a particular event, you are going to collect the elements from here. So basically E is the subset, right? Of what? Of sample space. That make sense?
Yes.
Yes, good. Okay, now we are going to answer these problems. Okay, an exam is given to a group of 120 students. Here, giving the exam is an experiment. So we are giving an exam, it is an experiment. The trial is one student taking the exam. So if you look at only particular student, just one incident, right? This is called a trial. But when you look at the students, the results or scores, which is called my outcome, right? Whatever the student's getting, which is outcome. Okay, so now look at the first, problem, and you are going to tell me which one is correctly experiment, definition suited, and the trial and outcome. Okay, look at first two, A and B. Which one is, correctly expressed like experiments? A or B? What do you think?
Is it B?
Very good. It is B. Whatever you are going to perform, which is your experiment. Yes, you are going to flip a coin. So which is going to be my experiment. So the correct answer is B. Okay. So we are going to do the things, right? That is going to be experiment. The first part A is the A answer is not suitable because you are not doing anything. You are just identifying. It is not going to be. So you are doing something, physical activities you could call. Right. Trial. Which one is going to be the trial? C or D?
D.
D. Yes. Trial means what? You are looking only one incident among those experiments. Experiment says that you are going to flipping a coin so many times maybe, but if you look at only single time, which is called your trial. So you are, flipping a coin only one, which is trial. Trial stands for the singular, so it's going to be G. Now, which one is suitable for the outcomes, E or F?
F.
Remember, outcome means what? You are going to get the results ultimately. Whenever you flip a coin, what is the result?
Oh, okay, so it'd be either heads or tails, so it'd be E.
E. It is going to be E. So your final answer, final result is called your outcome. So of course, when you flip a coin, my final result is going to be either the tails or heads. Therefore, my answer is E. Okay. So outcome is the ultimate, things when you perform an experiment. Right. So now we are going to identify, outcomes for event and the sample space. Example B is similar to the problems we did in chapter 5 under counting principles and all we did, right? Sample space. List all the sample space outcomes for the rolling a single die. So if you roll a die, of course, you will have 6 outcomes. Therefore, I'm collecting all the possible values, which is called my sample space. We denote by big letter S, right? Okay. Now, list the sample space for each of the following random experiments. So you are going to write the sample space. This is not new. We already have seen in chapter 5. 2 different dice are rolled once. How many outcomes we will have? Yes, go ahead, one of you.
2.
Remember, you are drawing 2 dice. You are rolling 2 dice. So we did the sample space problem in chapter 5. There are 6 possibilities in my first die. There are again 6 outcomes in my second die, right?
Mm-hmm.
So
12.
total outcomes is?
12.
No. 6 times 6?
36.
36, very good. Remember we did, there are 36 dots like that. There are plenty of outcomes, right? One outcome, maybe like 1,1. That means what? That means number 1 from your first die and number 1 again from your second one. And you may have 1,2. You may have 2, 2, and so on, right? And the final one maybe 6,6. So in total, you will have 36 outcomes in your sample space. Okay. So they are asking us to list everything. So you have to write all the 36. Now here, what is my, this is my experiment now. A single coin is flipped only once. Therefore, possible answers, you may have heads or tails. Therefore, 2 possible answers. So I'm putting under the parentheses and collecting both possible outcomes, which is called my sample space S here, heads and tails. Okay. But look at number 4. Now we have 3 coins, but we are flipping one by one, only once each coin. Therefore, how many total outcomes? Here I have, you will have now 8 outcomes. Why it is? Remember counting principles we learned in chapter 5. You have now 3 coins, right? Coin number 1, coin number 2, and coin number 3. You are flipping first coin. How many possible outcomes for first coin? There are 2. Second one, 2. And third one also 2 outcomes. So counting number principle says, in order to find total possibilities, you have to just multiply them. 2 times 2 times 2, which is 8. Therefore, you will have 8 outcomes when you flip 3 coins, right? One of those is this. You may have all 3 heads, right? So each outcome has now 3 components because you have now 3 coins, right? Look at the first outcome, H, H, H. What does mean by that? That means you are getting heads all 3 coins. This one, first coin, head, second heads, and third one is tails, and so on. So you should have 8 outcomes, right? Don't confuse. My one outcome is H, H, H. So you will have 3 components in your one answer because of 3 coins. Okay. Now look at number 5. Number 5 is sort of same thing. You are doing like number 4, but what is the difference there? Difference is in number 4, you have 3 coins. You are flipping one by one, but number 5, you have only 1 coin, single coin. Again, you are flipping 3 times the same coin, right? The concept is same now. You will have anyway same outcomes, right? Does that make sense?
Yes.
Yes. Again, you will have 3 components, right? But the explanation is different now because here in the problem number 4, you have to explain like that. The first coin heads, second coin heads, and third coin heads. But here, first time heads, second time heads, and third times also heads, right? But same answer, but same different explanation. Again, you will have 8 outcomes here also, right? So there are 8 outcomes. Okay. So if you have any question, please ask me, right? You can mute off and just ask. Okay, we have seen again number 6 problem, right? In chapter 5, drawing a card from a regular card pad. So if you look at there, how many cards there are in total? So here my sample space is all the possible cards, right? So it should have how many cards? 52, right? So you should have 52 cards in total. So this is my sample space now. Okay. Now, example C. Now we are going to define, any event E. So here in this problem, where's my event? This is my experiment now. You are rolling a die once. Therefore, if you look at your sample space for that problem, you are rolling only once, right? Therefore, you will have 6 outcomes now. Right? Now, they are asking us, hey,
Right.
could you, yes? Could you define now set E, event E? Event E is basically you are collecting the answers from these 6 possibilities. Event E is what? Rolling a number. That number should be greater than 4. So if you look at here, among these all the possibilities, what are the numbers which are bigger than 4? Of course, 5 and 6. Therefore, my event here is 5 and 6. So basically, you are getting an answer for E from where? From your S, from your sample space. Okay? So my event E is now here 5 and 6. Okay, so we are going to define E for remaining all the problems. Number 7. The experiment was what? 2 different dice are rolled at once. Remember again, you will have 36 outcomes for that. Among those 36, what is my event now? Event E is now, you have to get the rolling 2 numbers you are getting, but the total should be more than 9. Remember, these are the possible total you may have when you draw 2 dice, right? So, okay, so what is the minimum total you will have when you draw 2 dice? What is the minimum total? Then what is the maximum total? Yes. Minimum is? You have now 2 numbers, right? Where's my sample space now? My sample space has a 1, 1, 1, 2, and so on. 6, 6. Among these, Now you are adding two numbers, you should get the total, right? So the smallest possible total, 1 plus 1, which is 2, right?
Yes.
Then what is the maximum total? 6 plus 6, which is 12. So these are the maximum and the minimum totals you may have, but they are asking us, hey, could you define event E? The rolling should be more than 9. That means you may have 10, 11, or 12, right? You cannot exceed 12 because the possible maximum numbers are 6 and 6 from our dice, right? Okay, so if this is the case, now I am finding one by one. To get the total number 10, what are the possible outcomes you may have in your dice? We may have 4 and 6, or 6 and 4, or 5 and 5, right? Look at that. If you add these two numbers, always you will have 10, right? So these are the all, three possibilities you will have to get the number 10. To get number 11, you have to have 5, 6, or 6, 5. To get 12, only one possibility, which is 6 and 6. So I'm collecting all the possible answers for, all three numbers. So this is my collection of, all three. So that is going to be my event E now. Okay. Right. Now next experiment. A single coin is flipped once. Oh, then what is my sample space here? You are rolling, oh, you are tossing only one coin, so your sample space head and tail. It's and tails. Now what is my event E? Getting tails. So you have only one possibility, that is here. Okay. So your answer basically coming always from your sample space answer. Now this one, your experiment, 3 coins are flipped once, right? Therefore, this is like earlier we saw 3 coins flipping once. Where's that? We did just now, right? 3 coins flipping one. So you will have 8 outcomes in your sample space. But I need what? I need only 2 heads and 1 tails, right? 2 heads and 1 tail. You may have 2 heads, tail. You may have 2 heads, tail, and you may have like this, right? So this is going to be my event E. So there are 3 outcomes out of 8, right?
Yes.
Good. So next experiment, a single card is drawn from a standard deck. Okay. So now you are drawing only one card. So where's my sample space is there? My sample space is this picture now, right? You are drawing only one card. Then your event says what? Your event is what? You have to have face card. That means what? You just collect all the face cards from here. How many face cards we have in my sample space? These are all my face cards, right? 1, 2, 3, 1, 2, 3, 1, 2. There are 12 of them. So you just write down all the 12, right? So I just explained. J for Jack diamonds, Jack spades, Jack's clubs, and I missed one more, right? What is that? Jack hearts. And similarly, you have queen diamonds and queen spades, queen clubs, and queen hearts, and so on. So you have to have 12 outcomes there. So this is all about defining an event E. Now we are going to move into probability. Then how are we going to find the probability of an event E? To find the probability of event E, this is the formula we use. How do you read? P stands for the probability. The chance of getting that event E is simply given by this formula, NE over NS. What is NE? We have seen this notation in set theory, right? So little n of E means what? The cardinal number of set E. Here my set E is an event. So little n of E means you have to count how many outcomes are there in your set E. In other words, number of elements in your set E, which is n of E. N of S is in similar way the number of outcomes in your sample space. These two are simply numbers. So you have to plug in those two numbers and you will get a fraction. That is going to be your probability answer for an event. Okay? So if you want to find the probability of an event E, use this formula. Right? But this one is kind of special case. Suppose your event E is empty set. Right? Then the question is, then how do you find the probability of empty set? That means I'm again using this formula, right? I'm using this formula now. This is the formula we are going to use always. But now, you know, your event E is now empty, right? That means simply, change the letter E to empty. Therefore, E will be empty set over N of S. Now let's see who is telling. What is N of empty? One of you can tell me the answer. What is the cardinal number of empty set? Yes?
Nothing.
Nothing. Zero. Because empty set means nothing, right? You will not find anything inside.
Yes.
So that means N of empty is just zero over N of S. Zero over anything is zero. Therefore, empty set is always zero probability here. Okay? So the result, important result, probability of empty set is always zero. Okay? Now, if you look at the next thing here, this definition says the probability of what? S. S means sample space. Remember, sample space will contain all the possibilities, right? So in another word, we call the samples, the sample space S, you could call like a full set. That is full set. Why it is full set? Because we are collecting all the probabilities, all the outcomes. So this is empty set, this is full set. So the probability of full set is always what? 100%, right? 1. Okay? So the probability of sample space is always 1. These are the two main results we use, okay, hereafter. Now, these two are more likely to happen, less likely to happen. If the event, for sure, this event is more likely to happen, means the probability maximum should be 1, right? For sure, if you know the event is not going to happen, that means the probability is 0. That means what? That means the probability of any event E is always bounded by two numbers, 0 and 1. Okay? So your probability answer cannot exceed 1. So if you want to find the probability of any event, make sure your answer is always between 0 and 1. If you get more than 1, that means you made somewhere mistake. So you cannot have more than 1. Of course, 0 and 1 are included. You may have 1 and 0, no problem, because I have put equal sign here. Right. So the remaining problem, we are going to find the probability of event E. So which formula we are going to use now? So far, you have 3 results. What are those? The probability of any event E is given by N of E over N of S. The probability of empty set is always 0. The probability of full set sample space is always 1. Okay, remember these are 3 important points. Okay, so let's move and figure out the probabilities for the remaining problems. Okay, look at example D. We are rolling a single die. So we will find first sample space. Okay, for the single die rolling, we have 6 outcomes, that is here. Therefore, N of S is 6, right? What is the meaning of this? This means counting how many outcomes in your set S, 1, 2, 3, 4, 5, 6. There are 6 of them. Therefore, n of s is 6. List all the outcomes greater than 4. This expression is my event E now. My event E says what? I am collecting all the outcomes from your sample space S in such a way that your event E should have the number which is greater than 4. Among these all, what are the numbers which are greater than 4? Of course, 5 and 6. That is going to be my event E now, 5 and 6. Okay, so you have to write in clear way. Remember, E is an event, therefore you have to write in set notation. Okay, you see. Now find NE and P of E. NE, what is the meaning of NE? The number of elements in the set E. There are 2 of them, therefore N of E is 2. So once you know N of E, you know now how to find the probability of event E. What is the meaning of this? How do you explain now this guy in words? The meaning of this is the probability of getting what? Getting the total, getting the number, right? Which is greater than 4, right? That is the meaning, no?
Yes.
Because my set is the number getting bigger than 4. So this is the meaning. You have to put in this pattern. So that is the expression of, P of E. We are finding how much chance is there to get the number which is greater than 4. So that says that formula says P of E is N of E over N of S. We know N of E and N of S simply plugging the value. That means 1/3 chance. If you multiply by 100, that is approximately 33.33% chance there when you roll a die to get number 5 or 6, right? So that's the meaning. 1/3 of chance. Okay. Right. Are you following me or not?
Yes.
Yes. If you have any question, please ask me. Unfortunately, I don't see your face, so I don't know your facial expression. So, okay. Now, look at part D. Find the probability that we roll a number less than 4. Okay, now this is another event, right? Getting number which is less than 4. So I am denoting that event as F, right? So before going to find the probability, first of all, we need to figure out, the definition of this, the event E. So my event E here, E is, I'm just using different letters. So I'm using, instead of E, I'm using F. So my event F is here getting number which is less than 4. Okay, of course, if you look at your sample space, what are the numbers less than 4? Only 3 numbers, 1, 2, and 3, right? Therefore, my little n of F is 3 because 3 members. So the probability of F is now n of F instead of E. Now I have F. Therefore, you have to replace E by F. So P of F is given by n of F over n of S. N of F is now 3. N of S is again 6. So 3 over 6 is 1/2. That means what? That means the chance of getting 1, 2, or 3 is half chance. Yes, that is true, no? Why it is half chance? Because there are 6 numbers in your die, right? Out of 6, there are 3 here. That means the half chance is here. So that's why you get a half chance, makes sense. Okay, so let us look at number 11. We are rolling 2 dice now. Yes, now you have 36 outcomes, right? 36 outcomes. So you have to look at like X and Y axis, 6 and 6, 36. So if you have 36, then what is n of X? Just 36 outcomes of sample space. Now here, this is my event E. List all the pairs. The total should be 10, right? You have to get 10. Yeah, these are the three possibilities. We will have 10, 4, 6, 6, 4, and 5, 5. This is my event E. Remember, this is just one outcome. This is second outcome and this is third. Therefore, 1, 2, 3. There are 3. N of E is 3. Once you know N of E, we are going to find P of E. The probability of getting this event, number 10 total, is N of E over N of S. N of E is 3. N of S is, there are 36. So 3 over 36, which is 1 over 12. Okay. So do not round up your answer. Okay. Unless they ask you to. Otherwise, you have to write like exact. I'm writing an exact answer. Do not round up. Okay. When you do online assignments, they may ask you to round up, but in general, we don't. You write in exact answer. Okay. What is this even says? List all pairs with the total. You have to get the total which is more than 9. That means, remember, more than 9. Possible totals would be 10, 11, or 12, right? Maximum is 12. To get 10, 5, 5, 4, 6, 6, 4. To get 11, 5, 6, and 6, 5. To get 12, 6, 6. So these are the all possibilities. If you count the members inside the set F, 1, 2, 3, 4, 5, 6. So there are 6. Therefore, little n of F is 6. Once you know little n of F, we are good to find P of F, right? Using the formula and find 1, 6. Okay, that's good. But this guy is kind of different problem. Find the probability that we roll, the total should be less than 13. The total should be less than 13. What do you think? How many possible outcomes you will have in that set? Remember,
because you can only get 12 one way.
less than 13 means any number less than 13 is possible now, right? Right?
Yes.
So my minimum answer is now what? Minimum is 2, maximum is 12. They're asking, hey, could you find the total less than 13? That means all of them are going to be less than 13, right? Therefore, you have to write all the answers from your sample space. Therefore, this set, right over, this set is nothing but S, sample space. That is why the probability of S is now answer is 1. Because the possibility of being this event is all the elements from your sample space. Okay? Therefore, this is set S. Question is finding the probability of that set. So it is P of S. But we know P of S is 1, right? I already told you the probability of sample space is always 1. Look at here. Right? But if you look at this one also again, find the probability that the total should be less than 2. Is that possible to get less than 2?
No.
No, because the minimum is 2. You can't have less than 2. Therefore, this set is now impossible set, right? This is not going to be happen for sure. That means this set is now empty set. So the probability of empty set is always 0. Therefore, the probability of that event is now 0. So you have to understand the question carefully. Read the problem and ask yourself, right? So your set may be empty, your set may be full set, sample space, or maybe anything in between those two. Okay, I'm giving now 3 minutes. Could you read and understand this number 12? Let's see first. First try to understand. Read the question and make sure that you understand the answers. I'm giving 3 minutes. Okay. So we are flipping a coin 5 times now. Therefore, my sample space has now how many outcomes? 32 outcomes. Why it is now? Because remember in chapter 5, counting principle says what? If you perform 5 tasks, you have to count each task, right? You have to count how many outcomes there for each task, then you have to multiply them, right? Remember, you are tossing now coin 5 times. That means you have 5 tasks now. Each task has 2 possibilities, 2 outcomes. So therefore, you have to multiply all the possibilities 2 times 2 times 2, 2, 2, which is 32. Therefore, I have 32 outcomes in my sample space. That is why the number of outcomes in your sample space is 32, right? Right. So if you look at your sample space, there are 32 of them. One of these may be like this. My first flip, you are flipping 5 times, right? The first time maybe heads, second time heads, third time heads, fourth time heads, and fifth one also maybe heads. Or you may have heads, tails here, and maybe heads and like that, right? And so on. So there are 32 of them, right? But part B asked what? Calculate the number of outcomes with 3 heads, right? Now among these 32, you have to look at how many outcomes will have 3 heads and 2 tails. In another word, we have to have 3 heads, right? How do you find? For that, you could use the combinations we learned in chapter 5. Out of 5 chance, how many of them have 3 heads? That is 5 choose 3. Order is not important. I'm just looking how many heads we have out of 5. Therefore, which is 5C3. What is 5C3? Just type into your calculator. 5C3. 5. Go to math. Number 3 NCR. And type 3 and enter. 5C3 is 10, right? That is why we have 10. That means if you look at like this, writing all possibilities, you will see 10 are there like 3 heads and 2 tails, right? Therefore, the outcomes are 10. So once you know the number of 3 heads, this is my event now, E, getting 3 heads. Okay, this is our event E for this problem. This is my event E. So this is my N of E. This is my N of S. So in my event E, there are 10. My N of S is 32 because my sample space has 32, right? First part says that. Plugging those 2 numbers and divide them. It is going to be a probability of getting 3 heads. Okay. But part B is now super easy. You don't need to do, like that. Why it is 5/16? I just copy down the answer from part C for part D. Getting 3 heads is equivalent to getting 3 tails. Why it is? Why I put this answer? The probability of getting 3 heads and 3 tails are same. Why? I need your response. Anyone can give the answer. Are you there?
Yes.
Yes.
Okay, so then what is the answer? Why I'm writing these two same answer? You see now, the coin is very fair coin, right? Unbiased coin. Getting 3 heads equivalent to 3 tails because getting heads and tails are 50-50 chance. Am I right? Same chance, right?
Yes.
Yeah, that is why the probability of getting 3 heads should be equals to probability of 3 tails. Getting heads 3 times is, same as getting 3 tails because of, the fair coin. Half chance, right, for getting. So that is why both of them have same answer, right? So you don't need to do again like that. Answer is that similar. Okay, there are plenty of questions. Only thing is the probability questions, the thing is your answer is just one word, but the thing is you have to, understand the concept correctly and you have to put the numbers in proper way, right? Only plugging the numbers. So you have to, understand the definitions and the events correctly, and then only you will, get the correct answer. Okay, number 13. We draw a single card from a standard deck. Therefore, my sample space has 52 outcomes. So n of s is 52. Find the number of all kings. So what is the probability of getting king? Of course, there are 4 kings, right? In your card pack. Therefore, the number of getting kings is 4. Once you know n of king, then what is the probability of getting king? Formula says that. So this is my event now here, right? The probability of getting king. So P of E is n of E over n of S. The probability of getting king, n of E is 4, n of S is 52. Just simplify. Find the probability that you draw a card, that card should be face card. Okay, now in this problem, this is my event E, getting face card. Remember in your sample space, there are 12 face cards. So n of S is 52, so 12 over 52, which is, so if you divide by 4, you will get this, okay? I'm writing in fraction. So could you think about number 14? You understand the question? A car dealership finds that the certain model of the new car has something wrong. The probability of getting the transmission, fault is 15%. So 15% means how much? This is, there is 15% chance of, getting a fault mechanism in the car. So 15% means if you divide by 100, you will get 0.15, right? So that means what? This is the probability of getting, technical fault in your car. So now you have to think about this number. Is this very close to 1 or is this close to 0? What do you think?
1, right?
Is it close to 1? 0 is here. 1 is here. Central point is half, 0.5. This is 0.15. Where it is? Is this very close to 1 or 0?
1.
Are you sure?
No.
Where is point 0.15? 15 means 15, right? 0.5 means 0.50, 50. So 15 is, of course, going to be here, right, somewhere?
Yes.
So then what is your guess? Do you think that A is the correct one? Very likely.
No.
No, it is not. It is not close to 1. 1 is here, very far from 1, this number.
E.
So say it again. So let's look at the B. Somewhat likely closer to 1 than 0. No, it is close to 0. So it is not possible. Okay, your answer may be either 0 D, right?
Yes.
But if you look at these two answers, which one is, most suitable? 0.15 is much closer than 0, am I right? Much closer to 0, right?
Yes.
So that means this is the correct one. No, it's unlikely. We saw the probability is very close to 0. So it's going to be this one, right? If you see the number somewhere here, say you are getting one number somewhere here, then your answer is going to be D, right? Because this point is kind of closer to 0 than 1, right? But we all know that 0.15 is much closer to 0. Therefore, your correct answer is going to be unlikely. The chance is very less, right? Therefore, I'm choosing C. Okay, 15. A lake has 435 trout, 126 bass, and 628 catfish, 629 catfish. So there are 3 varieties of fish, right, in the lake. We randomly pick a fish from this lake. What is the chance of getting that fish as catfish? Understand the question? So probability of what? Probability of finding a catfish. This is going to be my event now. Do you see that? So they are simply asking, hey, what is the probability of getting catfish, right? So this is my event now, E. So that means the probability of E formula says what? That is probability of N of E over N of S. So that is what I have written here, you see. This is my event E. So the probability of getting catfish is N of catfish over N of S. How many catfish are there? The number of catfish, there are 629 of them, right? Over, what is my sample space? Remember, sample space means what? You are collecting all the possibilities. So there are 3 possibilities. So if you collect all 3 numbers and add them, that is going to be your little n of s. Okay? So remember, little n means the number, total number. You are just adding all 3 up. That is my n of s. So n of catfish is 629. N of s is the total of these 3 numbers. Put down. That is the fraction you are getting. So now I am approximating, right? So if you want, you could simplify this answer, and if you are getting very big numbers, it is okay to put like a rounding up, right? So I'm rounding up to the 3 decimal place. But I don't know about your online, maybe 2 decimal or maybe 4 decimal, according to the question you do. But now I'm writing in 3 decimal place, right? That means if you catch a fish randomly in that lake, if you multiply by 100 this number, 35% chances there to get catfish, right? That's the meaning. Right. Okay, for this problem, I don't want to use this formula at this point. So you can cut that. I don't want that. I'm doing in different way. What is the probability of getting not catfish? That means you have to catch the fish which is not catfish, right? Right. So how many are there which is not cat? That means except cat, you have to add remaining two. Am I right?
Yeah.
That is 435 plus 726. This is my, the not catfish. Then you have to divide by n of s. The total number is 79. So if you add these two numbers, you should get 1161. Okay. Is that okay? So if you have any question, please ask me. Okay, look at number 16. A bag contains 53 marbles, 11 of which are red. The marble is randomly selected from this bag and it is blue. This blue marble is not placed back in the bag. Now you are taking the second marble randomly, right? Find the probability that the second one is not red. Right? So that means there are 53 in total. You are taking one out, right? You are taking the first marble. They are telling that you are choosing the first marble, which is blue, right?
Yes.
Yeah. That means you are choosing a blue first time. That means now the leftover is 52 for second time, but still all the red marbles are there, right?
Yes.
Yeah, that means still level red are there still out of 52, right? That means now question is second time, what is the probability of the second time which is not red? Right? Okay. Remember, for the second time, I have now 52 in my sample space. Out of 52, how many of them are not red? Take away 11, right? 11 are red, right? So if you subtract 11 from 52, you will get the remaining which are not red, right?
Yes.
Yeah. That means that is 41 over 52. You see, understanding the problem. Okay. Right. Oh, now number 17, you are given a table. So look at the table and give the answer. The table to the right gives the age of 120 adults residents in a certain neighborhood, together with the information if they own or rent their home or apartment. So it is given information, right, though, whether they have a rented house or owned house. So the table is given for, according to age-wise. Okay, the question is now, you are going and you don't know who is, having rent or own houses. You are just going and simply picking one guy, right? So they are telling that if a random adult resident of this neighborhood is picked, you are picking just randomly one person and ask him whether he has own house or rented house, right? So now the first one is, what is the probability that that person you picked, right, has an apartment? That means how are you going to approach this kind of problems? Okay, I'm going and plugging, picking one person from all 120. So my total sample space has now 120. In another word, this is the total you see there. That is your N of this. Okay. Now look at the apartment. We are checking the probability of those who has apartments and who has apartments. So the apartment, which is the apartment or house which is rented, right? So look at the rented column. So you have to look at the rented column. How many are there in total? In total, there are 44, right? So that means there are 44 rental out of what? Out of 120. So that is going to be my N of S, right? So 44 over 120. So always the denominator is going to be the total elements in your sample space. Wherever you go and pick, that space, sample space has now 120, right? Now the second one, you are choosing a person. That person should be 14 to 59 years old. Now you have to look at the age. So 14 to 59, 14 to 49, and 14 to 59, 40 to 49, and 50 to 59. So you have to combine both, right? So now you're going to look at the age-wise. Therefore, 40 to 49, there are 40 of them. 50 to 59, there are 16 of them. When you add these two, you will get the total number of people, those who has in this age range, which is 40 plus 16. Again, you are choosing out of 120, so your denominator is always fixed for all three. But only the numerator you have to check, right? So 40 plus 16 is 56 over 120, was my second part. Right?
Right.
Okay, good. Now the last one, a homeowner. Oh, now you are looking for the home, right, owner between 30 to 49. Right, where it is. Now you are going to look at the owner, but the age should be 30 to 49, right? Therefore, 30 to 49 is these two now. But we are looking for the owners, so that means these two, 26 and 32, right? Out of 120. So that box, this box is going to be my part C answer. Okay, I'm leaving the last problem I'm not going to do. Why don't you think about this one? We'll explain next time, okay?